In this tutorial, we're going to learn how to draw contour lines. The process of drawing contour lines through a data set is a way for us to visualize the pattern made from that data. There's a variety of data sets that we might want to do or add contour lines to. We can use contour lines to help us visualize any type of data that has a spatial component. By that I mean a data set where the value of that data varies from place to place. What you're looking at here is a map of ground surface elevations measured at a number of locations. Obviously, the elevation of the ground surface varies from place to place. Drawing contour lines through this data set is a way to help us visualize what the pattern is. Any data that has a spatial component to it, a data set where the values vary from place to place, can be visualized using or represented using contour lines. For example, we could contour water table elevations, we could contour water pollution concentrations, we could contour intensity of earthquake damage. All of those types of data are examples of data sets where the value varies from place to place. Now, the process of drawing contours is not a connect the dot exercise. In other words, you're not connecting dots of equal elevation. Instead, you're drawing lines through the data set. Each line represents a value, and that line separates points of greater value on one side of the line from points of lesser value on the other side of the line. When you're asked to draw contour lines on a data set, you're often going to be given a contour interval to use, say 100 feet. In other words, you're going to draw a contour line every 100 feet, 100, 200, 300, and so forth. The 100-foot contour would have all the points less than 100 feet on one side of the line, all the points greater than 100 feet on the other side of the line, and of course pass directly through any points equal to 100 feet. Looking at this data set, we see values ranging from a low of 1490 to a high of 4097. If we did 100-foot contours, that would mean that we're drawing 26 contour lines, given the range of values we have here. That's probably more than we need. I'm going to start by drawing contour lines at a 400-foot interval. If that was not sufficiently detailed to represent the pattern in this data set, I could then add in 200-foot contours or even 100-foot contours if I wanted more detail. So drawing 400-foot contours, given our range of data, the highest contour is going to be the 400-foot contour, or 4,000-foot contour, excuse me. There's only one data point higher than 4,000 feet, and hence only one data point inside that contour. The next contour at a 400-foot interval would be 3,600 feet. All points greater than 3,600 feet, including our single point above 4,000 feet, would be inside the 3,600-foot contour, and all points less than 3,600 feet would be outside our 3,600 feet contour. As you're drawing your contours, label the value represented by each one so that you know what value that contour line represents. Keeping our 400-foot interval, our next contour line would be 3,200 feet. That line will pass very close to points that are close to 3,200 feet, such as 32,010 and 31,090, but those points will be on opposite sides of the line. 3,210 is inside the 3,200-foot contour. 3190 is outside the 3,200-foot contour. Our next contour is 2,800 feet. It will, of course, pass directly through any points equal to 2,800 feet. All points greater than 2,800 feet will be on one side of the line. All points less than 2,800 feet on the other side of that line. .400-foot interval. Next contour line is 2,400 feet. Again, separating points greater than 2,400 feet from points less than 2,400 feet. Our next contour is 2,000. Notice that I made a mistake previously. I have a point here, 2471, on the wrong side of the 2,400-foot contour. We're going to need to draw that contour again to include that data point. So when you're drawing contour lines, you want to make sure that you're using pencil so that you're able to correct any points that you may have missed or ended up placing on the wrong side of your contour line. This was the 2,000-foot contour that we drew. Our next contour is the 1,600-foot contour. Notice that we're starting to run out of data, so we don't necessarily have to close our 1,600-foot contour. In other words, make a complete loop. For example, in this part of the area, in this part of the map area, we have no points less than 1,600 foot. We have no basis for drawing the 1,600-foot contour in this area. We do have a point less than 1,600 foot here. Needs to be outside that contour. Another point here. That point's going to be inside. This point outside. That point inside. And there's no points less than 1,600 foot over here. No basis for drawing 1,600-foot contour. One more point over here that needs to be outside 1,600-foot contour. Now we've got a better idea of what this landscape looks like now that we've gone through the exercise of drawing contours in this data set. I did 400-foot contours. If I wanted to, I could add in additional contours. For example, I could draw a 2,200-foot contour. To show additional detail. I could even draw 100-foot contours, such as the 2,100 and 2,300. And I feel like I've done enough contour lines here. I feel like I've got a good sense of what this landscape looks like. This is a photograph of the area we contoured on the previous slide. This is Mary's Peak the high mountain which you see west of Corvallis. We're looking west in this photograph. In other words, we're looking at the mountain from this direction. Notice how the contours indicate a steeper slope on this side, a gentler, longer slope on this side, and a relatively flat plateau at the top of Mary's Peak. Do we see that reflected in the photo here? Yeah, we do. We see relatively steep slope on the south side of the mountain, gentler, longer slope on the north side of the mountain, and a broad, gently sloping plateau at the top of the mountain. The last slide illustrates the USGS topographic map for Mary's Peak. We were drawing a contour map of roughly this area. They've drawn 40-foot contours, so their map shows a much higher degree of detail than the map that I drew shows, because remember, I drew 400-foot contours. They have 10 times as many contours as I do, providing a map that's 10 times more detailed. Nonetheless, we see the same basic shape of the mountain, steeper slope to the south, longer, more gentle slope to the north, then a broad, relatively flat plateau that dips very gently towards the north.